next part is drives. Drives are devices which impart motion of the mechanical elements. Means these are the parts which are responsible for creating the motion. In a CNC machine tool, there are three major types of elements. First one is control and electronics. Then electric drives, that is electromechanical drives. Mechanical elements like table, slide, tool holder, etc. Most of the drives used in machine tools are electrical. The drives are classified as spindle drives and feed drives. Spindle drives. The following motors are used in spindle drives. DC shunt motor, that is separately excited. 3-phase AC induction motor. The requirement of a spindle drive motor are compactness, means that should be of small size, high overload capacity, large speed range of at least 1:1000, maximum speed up to 9000 to 20,000 rpm is required, high rotational accuracy is required, range of rated output is from 3.7 to 50 kilowatts. Wide constant power band is required. Fast dynamic response is required here, and excellent running smoothness is required. Then feed drives. The main component of a feed drives are a feed servometer and a mechanical transmission system. A feed motor, unlike a spindle motor, has special characteristics like constant torque and positioning. Means here constant torque maintenance and positioning is required. Following are the requirement of CNC feed drives. That is high torque to weight ratio, integral mounting feedback devices. During machining, the required constant torque for overcoming frictional and working forces must be provided. Low electrical and mechanical constant, low armature or motor inertia, permanent magnet construction, total enclosed non-ventilated design. Maximum speed is 3000 rpm here. Means the feed drive had less speed than the spindle drive. Then we will come to spindle. The spindle carrying the workpiece or tool when subjected to high cutting speed and high material removal rates experience deflection and thrust force. Means during the working it can deflect from its own position. To ensure increased stability and minimize torsional strain, the machine spindle is designed to be short and steep, and the final drive to the spindle is located as near to the front bearing as possible. Means to remove the deflection, we should use short length of the spindle. The rotational accuracy of the spindle is dependent on the quality and design of bearing used. The ball or roller bearing are suitable for high speed and high loads because of low friction, lower wear rate and lesser liability to incorrect adjustment and ease of replacement when necessary. Means here ball and roller bearing are used to reduce the friction. Spindle bearing. In modern machine tool, which employ high performance cutting tool materials, the design characteristics of spindle are used as follows. Minimum deflection under varying loads. Means when the loads are varying, the deflection created should be as minimum as possible. Long service life, good stiffness, good thermal stability, good running accuracy both in radial and axial direction. Axial load carrying capacity should be high. High speed of operation without creating chatter or vibration. The various types of spindle bearing used in the design of a spindle for machine tools are anti-friction bearing, hydrostatic bearing, and hydrodynamic bearing. This completes chapter 5, that is component of CNC machine. Thank you.